All right, so we got a fresh new equation, right? We haven't seen this one before. Um, let's take a look and see if we can figure out how to solve this thing, right? So now we're down at the let's balance some equations part of your note capture, right? So now we're kind of done taking notes. We want to make sure that we practice now. Okay, so don't spoil it for yourself, right? Make sure to pause me, right, as we're working through this problem, right? The very first thing you want to do is make a chart, right? So what I always tell people when we're working on this unit is the first step. Whenever you see an equation in front of you that needs to be solved, make a chart. Okay, and the chart should go like this. You should have every element that you see in that equation, right? So here, I've got this NA. Remember, um, what tells me that this NA is an element? I've got uppercase letter with a lowercase letter. I know that that's one element. Right. This guy, just an uppercase letter, I know that that's oxygen, and this uppercase letter, I know that that's hydrogen, right? Some of you like to write like Na, you'd write as like capital N and capital A. That's actually technically incorrect because you want to make sure the lowercase and the uppercase is how we tell the difference between these different elements, right? So Na, I know that's one element, and then O, and then H. So I've got three elements that pop up in this equation, right? And notice that you've got some N's on the left, you've got some N's on the right, some O's on the left, O's on the right, and so on. So I make a chart here that looks like this. So this is what you're actually going to draw on your paper when you're doing your homework assignment. Here, you're going to list your N's, your NAs, your O's, and your H's. And then the other important thing is you want to make sure to make a little T chart. And on one side, you want to put how many NAs, how many O's, and how many H's you have on your reactant side. And then how many NAs, how many O's, and how many H's you have on your product side. Okay, so you want to start off by just listing what's given to you. Before you start messing with anything, just list off what's given to you. So I know that on the left side here, I'm dealing with one Na, right? There's no subscript here, so I assume that's a one. I have one O and I've got one H, right? So I've got one of each reactant. And then on the right side, same deal, except now I've got some subscripts to worry about. I've got this Na with a 2 down here, right? So I know I have two NAs. Right off the bat, I know this equation isn't balanced because check it out. I've got one Na on the left and two NAs on the right. That's no good, right? So I got to balance this somehow, but not yet, not yet. The next thing I want to do is I want to look at the O's. Okay, the O's on the product side, on the right side of the arrow. I want to look at the O's and I want to say, okay, if there's one oxygen here, and you might be tempted to say, okay, look, I found the oxygen, good. I've got one on the product side, but you have to look at all of the molecules on the product side. So here you've got an H2O on the on the product side. So you've got one oxygen here and one oxygen here. That gives you a total of two oxygens. So when we say products, we mean all of the molecules on the right side of the equation. However many oxygens there are in all of these molecules. Doesn't matter if there's 100 of them, you have to count up, okay, how many O's do I have on the right side of my equation total? And then H's is the same kind of deal. Look at the H's, okay, there's a 2 subscript in front of the H. So I know that this equation is completely off kilter here because my reactants, these numbers should be the same and they're not. So I have to do something to my reaction to fix it. And we just kind of talked about in our lesson that the only thing I can do is change the coefficients, change the numbers in front where these blank kind of lines are here, right? So these blanks here are spaces to put in your coefficient. So if you think that you already have the kind of knowledge to solve it and you're confident, just pause the video right here before it gets spoiled for you and give this a shot and see if you're right. All right, so pause it right here if you think you got this. All right, so the right answer here is you want to take a coefficient of 2 and put it in front of this this NaOH on the left side of the equation, right? Because what this does is, for example, if I'm just looking at my first element, sodium, right? I know that the product side has 2 sodiums, right? And I know that my reactant side only has 1. So I'm starting to think, okay, what can I multiply times 1 to give me 2? I want to make sure that these numbers are equal. So I got to make sure that this Na here on the left side, that I have 2 NAs over here. So the only thing I can do is bring another molecule of this NaOH to the left side. so that my number of each atom, of each type of atom, will balance out. So after putting this 2 here, right, now I've got 2 times 1, or there's a 1 here in front of this Na. So now I've got 2 NAs on the left side. And now, because these guys are all put together in one molecule, I've got 2 times 1 for oxygen here, right? Remember, there's nothing in front of the oxygen, so that right there tells me 2 oxygens. And then for the hydrogen, same thing. I got 2 times 1 hydrogen, right? Remember, you have to think of these elements as individual, right? These are all put together in a molecule, but when you're filling out your chart, you want to make sure that you kind of distribute this coefficient to each element as you're filling out your chart. Okay, so 2 times 1, 2 times 1, and 2 times 1. And that gives me, okay, 2 NAs, 2 Os, and 2 Hs. That gives me equal amounts for each element on both sides of the equation. My coefficients then are 2, 1, and 1, right? So 2 in front of this guy, a 1 here because there's nothing there, so it's just 1. And then same thing here, there's nothing there, so it's just a coefficient of 1. Now 2, 1, 1, no least common factor. I can't divide by anything, so this must be the correctly balanced equation. Right? So if all the atoms are equal on the left and right, reactant and product side, then your equation is balanced and you're good to go. Okay. Now, let's try a couple more examples. These ones, I'm not going to explain as thoroughly. I really want you to take a minute to pause the video and to try them for yourself, right? So you got 2 coming up. The first one here is you've got Fe plus O2 yields Fe2O3, okay? And the thing I want you to practice here is instead of actually making the kind of big chart that we made in the last example, you don't have to kind of spend time making all those lines and whatever for your chart. You can actually just kind of make like a little T-chart or maybe even just a little line, and you can kind of just put and list the elements that you find in your equation, right? So I see an Fe on the left side, so I'm going to make sure to make kind of like a row for Fe's on the left side of my equation and on the right side of my equation. And then the same thing for O's. I see an O here. So then down here in my chart, right, and this is kind of like on the off to the side on your paper, you kind of make a little line, or maybe underneath the equation, you make a little line right where the arrow is, and then you list out all the elements that you have in your equation. So I've got 2 elements, right? I've got Fe and I've got O, and they show up on both sides of the equation. So I'm going to keep track of the number of each element with this little kind of line graph, right? So it's kind of just a shorthand way of counting these atoms. Okay, so the first thing you want to do when you're doing, whether you make a full chart or whether you make this kind of little shorthand chart, is you want to count what you got so far. Before you fix anything, you want to count what you got. So Fe, right, on the left side here, there's no subscript and there's no coefficient, so I just have 1 Fe. That's where this 1 comes from. And then for oxygen, right, you guessed it, 2, right, because I got a subscript of 2 here and no coefficient, so I only have these 2 oxygens here on the left. And then on the right, I look over at this guy. Now these 2 are joined together in a molecule, and I've got 2 Fe's and I've got 3 oxygens. Okay, so this is my initial count. And realize things are all out of whack here, right? I've got Fe's not matching up, I've got oxygens not matching up, so I'm gonna have to fix this equation. I'm gonna have to balance this equation. Okay, so pause the video right here, give it a shot, right? And then see if you get the right answer, which I'll explain in a second. All right, so here, right, the approach you want to take to doing this is you've got this on your paper, right? You've got your initial Fe's and your initial O's, right, on your paper, and realize that the easiest thing to look at is just look at one element at a time, right? So I'm going to start by saying the easiest thing for me to fix are these Fe's. I'm going to ignore the oxygens for now. Don't even look at the oxygens. Just focus on the Fe's, right? So how do I fix these irons? Okay, so I've got 2 irons over here on the right, and I've got 1 iron on the left. And so the way I want to start by fixing this is, I've got a 1 here and a 2 here. I know, just easy math, right, that if I add a 2 coefficient here, all of a sudden, my number of Fe's on the left is going to go to 2 because I've got a subscript of 1, and I know that 1 times 2 is going to give me 2 Fe's. So right off the bat, I've already fixed my iron problem, right? I've got 2 irons on both sides now, 2 on the right and 2 on the left. Okay, so now I got to fix my oxygen problem. So 2 and 3, if I multiply 2 times 2, I get 4. But if I multiply 2 times 3, I get 6. Those don't add up. Let's take a look. Let's see if I can find a number that they both agree on, right? So if I put a 3 here, right? 3 in front of this O2, let's see, how many oxygens will that give me? That'll give me 3 times 2, that'd give me 6 oxygens. Okay, right? Because 2 times 2 would give me 4, but that's not divisible by 3. So if I go up to a coefficient of 3, that gives me 6 oxygens on the left. Now I have to make sure my oxygen's on the right. Remember, don't look at the Fe's while you're fixing the oxygens. Only focus on one element at a time. Right now we're fixing the oxygen. So here on the left, okay, I made this into 6. And then on the right side, to make this into 6, I'm going to have to put, right, you guessed it, a coefficient of 2 here. Because this 2 times the 3 in front of the oxygen, right? Remember, you're distributing this coefficient. The 2 times the 3 in front of this oxygen is going to give me 6 oxygens on the right, right? But now I've done something, and this is why I said trial and error is the best way to solve these, because, oh man, I just messed up my number of irons here, right? So by putting this 2 in front of this molecule, right, now I have 2 times 2 irons, Fe's, and on the right, I've got 4 irons. So now I have to go back and make sure that the irons here on the left add up to 4, right? So that's an easy fix. I can take this coefficient of 2 and make it into a 4 instead. And now I've got 4 irons on the left, right? I've got 4 irons on the right, and I've got 6 oxygens on the left, and I've got 6 oxygens on the right. So now each type of element is balanced and my equation is balanced, right? And so I got these coefficients of 4, 3, and 2. So on your paper, on the practice section where it says coefficients, these are the ones you want to make sure to list. Or you can write them right in the blank spots, right, where your equation is written, right? But the idea is that you're going to have lots of eraser marks. You should have little tallies, or you should have, your paper should kind of look like this by the time you're done balancing the equation, because you're doing trial and error. So there's no shame in making sure to, and having a lot of eraser marks and, having things crossed out. It should be trial and error, right? And some of these equations get pretty tricky to solve. So the coefficients 3, 4, and 2, they don't have a least common factor. So these guys, that's the simplest coefficient set, and you can't reduce these, and so your equation is solidly balanced. Okay, so that's the right answer for the first practice problem. Now let's take a look at the second practice problem. And this one's going to be a little bit tougher, right? But realize that the exact same rules are going to apply to this one. And then after this, we're going to call it a day with the mini lesson, and you're going to have some homework practice to actually turn in for a grade. Okay, so let's take a look at one last practice problem. Let's take a look at this guy here. And so we're still on your note catcher. You should have an equation that looks just like this. Okay, so just like before, what we want to do is we want to make sure that we list out all of the elements. Just because there's a lot of them this time around doesn't mean that we want to change any of the rules. So the very first thing, you see an equation of balance, you list out all the elements on a little kind of T-chart. right? So you have one column for the left side, the reactant side, and one column for the product side. And so what we look at this equation and see is we got aluminums hanging out, right? ALs. We've got nitrogens, right? We've got oxygens. We've got some hydrogens and some sulfurs, right? So we've got all of these different elements hanging out somewhere in this kind of, jumbled mix of molecules. And so just because it might look a little bit intimidating, you got these parentheses hanging out, it doesn't make it any different from the ones we've solved already so far. Okay, so uh, let's take a second and analyze this thing. So we got aluminums first. Okay, so we got um, one aluminum, right? We're on the left side on the reactant side of this equation. We've got one aluminum hanging out here. And how do I know that? Well, I've got nothing in front of the subscript in front of this AL. So even though it's attached to this whole thing with parentheses and a lot of little subscripts and all that stuff, in front of this aluminum, there's nothing. There's no subscript. And on the left, there's no coefficients. So for this aluminum, I know that I have one. Okay, now for nitrogen, it's a little more complicated. It's inside of this parentheses. And so first, just focus on the inside of the parentheses, right? In here, we've only got one nitrogen hanging out, right? Same as the aluminum, there's no subscript here on the right of this end. So I know that there's only one nitrogen inside of the subscript. I'm sorry, inside of this parentheses, right? But outside of the parentheses, we've got this 3 hanging out here, right? And so just like you might have learned the distributive property way back in the day, we want to take the 3 on the outside of the parentheses and distribute it to everything inside the parentheses. So this 3 gets multiplied by the number of oxygens, and it multiplies by the number of nitrogens. So for nitrogens, I've got 3 times 1 gives me 3 nitrogens in here. Okay, and then for oxygens, the same deal, right? I've got 3 times 3. I've got 9 oxygens here. But hold on a second. I also have oxygens hanging out here in this molecule, right? Remember, this chart is for each different element, the total number of that element on the entire left side of the equation. So I have to add the oxygens, right? I don't care if they show up in 100 different compounds or molecules. I have to add all the ones that show up on the left. So here I've got 3 times 3, I've got 9 oxygens in this molecule, and then I've got 4 oxygens in this molecule. So I've got 13 oxygens on the left side. And then the same thing for H, this one's a little easier. You got a subscript of 2 right here. And then for S, sulfur, you've got a subscript of nothing, so it's 1. Okay, so the same thing for the right side. We see the aluminum's got a subscript of 2. We see that this S inside the parentheses has no subscript, so it's just 1, right? But there's a subscript outside the parentheses, so we have to distribute this thing. So 3 times 4 for oxygen, and then 3 times 1 for sulfur, okay? But we have to follow the order of our chart, right? So we look at nitrogen next. Here, no subscript in front of nitrogen, so there's just 1. For oxygens, we've got 3 oxygens over here in this molecule, and then we've got 3 times 4, 12 oxygens in this molecule, right? So be careful here, because I've got 12 oxygens here, and I've got 3 oxygens here. We have to add them up for a total of 15 oxygens on the right side, right? Remember, we're adding up all the oxygens on the reactant side, on the right side of the equation here. Okay, and then we look at hydrogens. No subscript, so there's just a 1 here. And then sulfur, remember, inside the parentheses, no subscript, there's just a 1 here. And then we distribute this 3, so I've got 3 sulfurs. Okay, now I'm looking at this chart and I'm checking to make sure that my law of conservation of mass is being followed here. And I realize that this thing is breaking the law of conservation of mass all over the place, right? None of these numbers match up when they should all be the same for the reactants and the product side, right? So I'm gonna start with the easiest number to fix. And it's always gonna be if you have a 1 and a 2, right? That's an easy fix, right? If I look at these aluminums, okay, I've got 2 on this side and I need to have 2 on this side. So I'm just looking at aluminum, ignore all the other elements. We're just fixing aluminum right now. So the way to fix aluminum, you guessed it, because I only have 1 aluminum on the left, I have to add a coefficient of 2. right here in front of this entire molecule, right? Because aluminum is part of this molecule. I can't separate that molecule. I have to add a coefficient in front of the whole thing. Okay, so that 2 times the 1 in front of the aluminum, that gives me 2 aluminums now on the left side. So now my aluminums are fixed, right? Because I got 2 aluminums here on the right, and I've got 2 times 1 aluminum here on the left. Okay, the aluminums are good. Now I'm going to move on to the next easiest element to fix, right? So that's going to be nitrogen. So if I look in here, here's my nitrogen. I know I have 3 nitrogens on the left, right? But now that I've put this coefficient in here, right, it gets a little more complicated. So I've got 1 nitrogen in here times this 3, right? This coefficient, I'm sorry, this subscript of 3, 3 times 1 gives me 3 nitrogens. But now I've got a coefficient of 2. So I've got 3 times 1 gives me 3 nitrogens, and now I've got 2 times 3 gives me 6 nitrogens now. Okay, so let's pause right there. Now I have 6 nitrogens on the left, and I've got 1 nitrogen on the right. So I'm gonna fix the number of nitrogens on the right now because I wanna make sure that it matches the 6 that I now have on the left. So an easy way to fix the number of nitrogens here is to add a coefficient of 6 here, okay? Remember, don't look at any other element until you're done with nitrogens right now, right? So until you fix the element you're on, don't worry about any other element. So now we have 6 times 1 nitrogens. We have 6 nitrogens on the right. 6 times 1. Okay. So now the nitrogens are good and the aluminums are good. So let's move on to the next element we can fix. Okay, so that's going to be hydrogens. So let's take a look here. And then how do I know what element to move on to next, right? So I've fixed these two. Why not just move on to oxygen? Well, a rule of thumb to follow is you always want to fix the easiest element to fix, right? You don't want to go right into the toughest element, like 13 and 15. Those are kind of tough numbers to fix when we can fix 2 and 1. We can fix the hydrogens pretty easily because I know they have lots of common factors. So here I look at what I've now done is I've put a 6 in front of this molecule here. And so now I know I have 6 hydrogens on the right side of my equation, right? 6 times 1. So I fix my chart. I'm always updating my chart. You're always crossing out old numbers and writing in new numbers as you add coefficients. So I'm looking at my hydrogens. Okay, I've got 6 on the right side and I've got 2 on the left side. And so then I know I'm going to add a coefficient of 3 right here where the hydrogens are on the left side, because I need to make sure that I do 3 times 2 in order to get 6 hydrogens, right? Think of it like a math puzzle here. You're just fixing each little element until the whole thing is fixed, okay? So my hydrogens are good, and I like to actually do little check marks. So once I fix the aluminums, I put a check mark next to them, and then a check mark next to the nitrogens, and then a check mark now next to the hydrogens, right? So you might have this on your paper. The next easiest one to fix is going to be the sulfurs. So I look down here and I say, okay, look, I've got how many sulfurs on the right side? I've got 1 inside of this parentheses and then multiplied by this 3 outside of the parentheses. So I've got 3 sulfurs here on the right side. And then I look at my left side and I realize, okay, so I put this 3 here to fix the hydrogens, but what does this do to the sulfurs? Because I have to distribute this 3 to each element, right? So 3 times the 1 sulfur in this molecule gives me 3 sulfurs on the left. So it turns out that my number of sulfurs was already fixed, right? And so here we fixed oxygens, but realized that sulfur was already fixed by putting this coefficient in here, this 3 here in front of this H2SO4, okay? So let's take a step back and look at the oxygens. Okay, so here it looks like we have, now there's a lot of oxygens, right? Oxygens are kind of a pain in the butt in chemistry because they're in so many different molecules that it's a little tough to keep track of them when you're doing this balancing, right? But just kind of think of it like a puzzle here. So for this molecule, I've got 6 times 3 oxygens, right? I've got 18 oxygens here, okay? in this molecule, but there's also oxygens in this molecule. So I have 18 in this molecule, and then here, 3 times 4 gives me 12. So I've got 12 times 18, I've got 30 oxygens on the right side. And then if I go over to the left side, right, if I go over here, I look at this, 3 times 3 gives me 9, right? First got to do this distributive property here for this subscript outside of the parentheses, and then times 2 gives me 18 oxygens. Okay. Now I look at what I've done here by adding this coefficient of 3, and then I've done 3 times 4 gives me 12 oxygens here, right? So 18 plus 12 gives me 30 oxygens on the left, and then this 18 plus 12 oxygens gives me 30 on the right. So my oxygens are good. I've got 30 on both sides, and then last but not least, my sulfurs are good because I've got 3 times 1 sulfur, and then I've got, right, there's a 1 here, 3 times 1 sulfur. All my elements now are good because they have the same number on the left and on the right for every single element type. So my equation is balanced. And I look at my coefficients, I've got 2, 3, 1, and 6. These, they don't have a common factor, right? I can't divide each of these by the same number and get a whole number out of them. So I know that they're in the lowest form. I know that my equation is balanced and that my answer is correct. Okay, so this was kind of a tough problem here, and on your homework set, you might encounter maybe 3 or 4 of these kind of more involved equations to balance. But as long as you remember to make your chart, and as long as you remember to go one element at a time, I think that you're going to get some good practice balancing these equations, and then you'll be able to kind of design and kind of see some really cool reactions, and then work in a little bit more math so that we can do some other pretty cool stuff in chemistry. But here, this is where it all starts, balancing these equations here. Okay, so I'll stop right there. I'll call it a day because I've been talking for way too long. And you're going to want to get practice in for homework. The homework assignment looks just like this. Okay, so if you don't have access to a printer, don't worry necessarily. You just want to make sure, maybe on a blank sheet of paper, jot down here the different equations, and then give balancing them a shot. Okay, and so you see that some of these have the subscript thing that we kind of talked about in the very last example, but for the most part, it's just more practice with these balancing equations, and then making sure we understand, okay, how do I actually say a reaction in words, not just write them down and balance them, but how do I actually communicate a reaction? And then a few symbol questions, right? So there's some symbols in these chemical reactions. It might take a little bit of research, right? But take a look here at what these symbols mean, how we say them, how we use them, and you'll turn this in either in Google Drive, or you'll email me a scan or a picture of the completed assignment. Okay, so really getting some good practice in balancing these things, making little charts, use extra paper if you need to. This is really all about pencil to paper practice. Okay, so I should see little charts all up and down your paper that list the different elements, and you should be doing trial and error, crossing off coefficients and erasing, and until you get a balanced equation. Okay, and so as always, feel free to drop into office hours. They're posted on the Google Classroom in that schedule, that picture schedule. You can use the tiny URLs to log into any of our Zoom links if you're struggling with any of this. And good luck.